Hey everyone, so we spent a bunch of time working on this shooter prototype. Actually, we decided to just completely rebuild it from scratch. And really the focus on here was rigidity. This thing vibrated a ton, and when you're spinning a wheel at between 5,000 and 6,000 RPM, vibration is everything. So this time we used some of our pitch plate along with our hex bearing blocks, so that now you have a top and bottom ball bearing. That makes this much smoother. But also by boxing in the frame here, this whole thing is a lot more rigid. Rigidity, I think, is going to be the key with consistency here. We have done a little bit of adjustment on the compression, but I'll get into that. But let's take a look at kind of where we're at. Matt? I can consistently hit that logo. There we go. So not too bad for a prototype that I'm holding my hand. I think we may do a little bit more testing on this, where we actually try to play with the angle and put something here so that we can actually mount it to see it gets consistency. One of the other things that we noticed a lot, you might have saw me adjust it during the video, is that when they come out like this, they actually get a kind of a curve to them. So that is something that we're going to have to kind of the teams are going to have to take a look at. Also, this is just running raw motor control based on the interface software. So I think that when we start looking at wheels, you definitely want to look at like the PID and actually controlling the velocity on these. All that's going to really help with consistency. I'll take this back into our studio, kind of walk you through some more of it, and we'll check back in. All right, so shooting and shooting prototypes is always a lot of fun. I thought I wanted to go over this just a little bit so you got a deeper, closer look at it. As I mentioned before, we're running 2 HD hex motors, 1-to-1 through ultraplanetaries. The nice part about that is it gives you a really nice bearing when you're going fast speeds. These wheels 1-to-1 are between 5,000 and 6,000 RPM, so that's quite a bit. We're using bar up on top, so this whole thing is really rigid, but it's really important to point out, like, we're using a ball bearing block on the top. So this is our mounted hex bearing. One of the things I really wanted to point out here in this video was about compression, right? So compression is all about, you want no slippage, and it's how much energy exerts to it. We are able to slide this wall in and out. So we were doing this on the fly when we were shooting on the field. And when I got to the most consistent shots, the compression is actually quite a bit. So this is actually squeezed down quite a lot, and it didn't seem like it slowed the motors down, and they were actually shooting rather straight. So there's definitely a lot more testing that would have to get done to tune this in. We've decided to kind of leave this as is, just kind of leaving this from an idea inspiration standpoint. But we really like the performance of the 2-motor solution with the 2 wheels in line. There's no grip here. This is all very nice and smooth on that side. I know in the past some people have said that maybe putting some friction material here, you might be able to get away with less compression if there's a friction material here. And then the other thing too is in the software. So we were running this straight voltage control, so just hooked up all the way. We weren't monitoring our battery voltage. We weren't monitoring any part of that. So you really, really want to be able to control the velocity on this, because as a match goes on, as the event goes on, you don't want to just randomly have your shot changing how far it can go based on whether you have a good battery or not. So you really want to do closed loop control using the encoders on these motors. We're going to try to get an example up of how to do that on the docks up here in the next week or so. And but this is a good framework or a good place to start. There are going to be lots and lots of solutions on how to shoot these and score into the high goal. So this is just one example from less than 48 hours of tinkering around with it. And so if you've got any questions, feel free to shoot us an email, and there'll be more information about this shooter and our other prototypes on our documentation site, docs.revrobotics.com, and there'll be a link for our prototyping. So we'll check back in later to wrap this up.
Tell me when.